welcome back to BPSC Learning, YouTube Learning, BPSC Learn from Home. Today we shall start a new chapter in 10th standard physics, machines. Okay. So before we go for the higher topics in machines, let us first know what is the definition of a machine. A machine is a device used to overcome resistance, to gain speed, to change the direction of effort, to do dangerous work where human beings cannot be employed. So, in a broad sense, how we can define machine? It is used to overcome the resistance. Used to overcome the resistance means you can lift loads by using machines. To gain speed, you can increase the speed of the work done, understood, by using a machine. Then, you can change the direction of effort. So, if you are applying effort in upward direction, then it will be very difficult for us. For example, you take water being drawn from the well. When water is being drawn from the well, what we will do? Instead of pulling the pot of water with our hands, is it not manually? We will fix a single fixed pulley and we will employ the pulley. We will use the pulley. When you use the pulley, what happens? The direction of the effort changes and you can lift the pail of water very easily from the well. Okay, so remember, a device used to overcome resistance means to lift loads, to gain speed. You can increase the speed of the work done, to change the direction of effort. Then you can do some dangerous works also where human beings cannot be employed by using a machine. So, if you want to lift tons of very heavy loads, then it is not possible for human beings to do that work. In such cases, you can employ a machine. So, this is in broad sense the definition of a machine. Now, this definition of a machine can be used, applied to uses of machines also. So, what are the uses of machines? Uses of machines is you can lift heavy loads, right? Then you can increase the speed of the work done. Then you can change the direction of effort. You can change the direction of effort. You can employ to do dangerous works, harmful and dangerous works. So this is in broad sense the uses of a machine. So please note down this. Next we shall come to the broad classifications of machines. So machines, there are various types of machines. Now how they are broadly classified, you see. Machines can be classified as levers, okay, and then inclined plane. Then in levers we have again pulley and then wheel and axle. In inclined plane you have wedge and screw. So this is in broad the classification of machines. Now mainly in this chapter for this year we are focusing on pulley systems only. Understood? Before that, we have to learn some of the terms related with the machines. So, this is the broad classification of machines. Once again, I repeat, machines are classified as levers and inclined plane. Levers are further classified as pulley and wheel and axle. Inclined plane is classified as wedge and screw. Okay? So, note down this. Next, we shall come to some of the general terms related to machines. So which are the general terms related to machines? First one is load. Load is represented by the letter L. Now what is load? The resistance to be overcome by the machine. Is called load. So the resistance to be overcome by the machine. Already I told you what is the meaning of resistance. Means you want to lift an object. Then that is called resistance. Okay. So whenever you are lifting an object, what you are doing? You are doing work against gravity. Gravity is acting towards the center of the earth. But when you are lifting an object, you are doing the work against gravity. So there will be some resistance offered when you are lifting the object, and you have to overcome that resistance. So load is nothing but the object which is to be lifted by the machine, or you can even tell the resistance to be overcome by the machine is called load. And remember, load is represented by the letter capital L. Okay. Next term is effort. Effort is represented by the letter E. The force applied on the machine. The force applied on the machine to overcome the resistance is called effort. Okay, so when you want to lift some load, you have to apply some force, is it not? And you are not applying force manually. Here you are using a machine. By using machine, you are applying some force. That force applied on the machine to overcome the resistance is called the effort. Note down this definition, children. So remember, load is represented by the letter L. Effort is represented by the letter E. Now, third one is mechanical advantage. Mechanical advantage, usually we will write it as MA for shock. So you can just define it as the advantage given by the machine is called mechanical advantage. Understood? The advantage given by the machine. So when you are using a machine, you are getting some advantage. Means you are able to do the work very easily. Using less effort, you are going to lift very heavy loads. So that is called advantage. The advantage given by the machine is called a mechanical advantage and is represented in short as MA. And it is also defined as the ratio of load to effort. The ratio of load to effort is called mechanical advantage. Is called mechanical advantage. Load means, I told you, represented by the letter capital L. Effort is represented by capital letter E. Now, mechanical advantage will be equal to load by work. This you also remember. Mechanical advantage is represented as load by effort. Ratio of load to effort is called mechanical advantage. So you can refer your textbook also for these terms which are used in machines. Understood? So in mechanical advantage, we have two types of mechanical advantage. One is ideal mechanical advantage and the other is actual mechanical advantage. advantage. So now I have told about mechanical advantage is general. Little later on I will be telling you what is ideal mechanical advantage and what is actual mechanical advantage. For now you remember that mechanical advantage is the ratio of load to effort. Please note down these definitions. Now, after this, the next term is input and output. Fourth term is input. Input means the work done on the machine. The work done on the machine is called input. So if you want to do some work, then you have to apply force on the machine. That force applied on the machine or work done on the machine is called the input. Input usually we will write in short as I bar P. Is it not? Now here I told you input is nothing but the work done. Now when I say it is work done, then what is work done? We know that work done is equal to force into displacement, right? Force into displacement. Now you are doing some work on the machine, means you are applying some effort on the machine. Now if you take the displacement of effort, if displacement of effort is D, if displacement of effort is D and the force applied is F, then work input will be equal to force into displacement. This relation you have to remember. So work input is nothing but the work done on the machine. Now work done is nothing but work done is nothing but force multiplied by displacement. Now if you take the displacement of effort is capital D and force applied is capital F, then work input will be equal to F into D. Likewise, next term you remember output. Output is nothing but the work done by the machine. The work done by the machine is called output. The work done by the machine is called the output. Now again work done means what? Work done is nothing but force multiplied by displacement. Now if displacement of the load, now when the work is done by the machine, what is happening? Whatever load that we have to lift, that will be done. The load will be lifted by the machine. Then the load will move to certain distance. Suppose the load is on the ground, you are lifting it to a certain height. Then if the displacement of load is small d and force applied is F, then work output will be equal to force multiplied by displacement of the load. So remember these two, work input and the work output. Okay, please note down. So Remember, input is nothing but the work done on the machine and output is nothing but the work done by the machine. Whether it is input or output, here work is done. So, I am substituting for work done force multiplied by displacement. Capital D, if I take the displacement of effort as capital D, then the input will be equal to F into D. If I take the displacement of the load as small d, then work output will be equal to F into small d. Okay. Now the next term is principle of a machine. Principle of a machine. Now principle of a machine is what? Work done on the machine will be equal to work done by the machine. This is the principle of a machine. Okay. Work done on the machine will be equal to work done by the machine. This is the sixth term. So from the beginning, once again I will tell which are the terms we have learned. First is load. Load is nothing but the resistance to be overcome. Second term is effort. The force applied on the machine is called the effort. Third term is mechanical advantage. So what is mechanical advantage? It is the advantage given by the machine and it is the ratio of load to effort. That is the third term. Fourth term is work input, work done on the machine. Fifth term is output, that is work done by the machine. Sixth term is principle of a machine. Understood? So what is the principle of a machine? Work done on the machine will be equal to work done by the machine. Next, seventh one is velocity ratio. And it is represented in short as VR. Okay. Now what is velocity ratio? The ratio of velocities of effort to load is called velocity ratio. Now see here, suppose you are using a pulley, and you are lifting some load. Here load is there. You have to lift this load to a certain distance. Then what you will do? You will apply the effort here, right? In this direction you are applying the effort. When you are applying the effort, for the pulley you are tying a rope to the groove, is it not? And one end of the rope is tied to the load. This load has to be lifted. And where you are applying the effort, you are applying the effort here in the downward direction. Okay. So when you apply the effort in the downward direction, then what happens? This effort, this rope will move to a certain distance. Is it not? So that is called distance moved by the effort. The rope will move through certain distance. That is called distance moved by the effort. And the load will move up. That is called the distance moved by the load. That we have to remember. Okay. So when the effort is applied, here the rope will move through a distance downwards, and the effort, this rope will move upward through some distance. And also here time is going, it is not stopping, time is going, and hence we can just come to the conclusion that there will be some velocity of the effort and also velocity of the load. Because when you are applying effort, the effort moves through some distance and even load also moves through some distance. And here you can calculate the velocity of effort and velocity of the load also. If you take the velocities of effort and velocity of load and take their ratio, then it is called velocity ratio. So, velocity ratio is given as velocity of effort by velocity of load. This is in precise the definition of velocity ratio. Now, as I told you, velocity is nothing but what? Velocity is nothing but displacement by time taken. Already in previous definition I told you, the displacement of effort is to be represented by capital D and the displacement of load means you have to represent by small d. So, this is velocity of effort, this is velocity of the load. Now, I will substitute here the velocity of effort and velocity of load. Look here, velocity ratio will be equal to d by t divided by d by t. Now, how much you will get? dt will get cancelled. You are left with the d by t. Now, what is d? d is displacement of the effort or distance moved by the effort. Then, what is small d? It is displacement of load. Right? So, you can even represent velocity ratio as the ratio of displacement of effort to displacement of load also. So, what is capital D? D is displacement of load. Sorry, displacement of effort. Small d is displacement of load. So, remember here we have two definitions for velocity ratio. Which are those definitions? One definition is it is the ratio of velocity of effort to velocity of load. Now, if you take the other definition, here I am substituting instead of velocity d by t. Is it not? So, when you substitute d by t, you will get velocity ratio as displacement of effort by displacement of load. But in examination, if you are asked to write velocity ratio definition, better write this definition only. In precise, velocity ratio is the ratio of velocities of effort to load only. So, this will be the very correct definition of velocity ratio. Understood? So, this is the seventh term which you have to remember. Okay. Now, next term we shall go now. That is efficiency of the machine. Efficiency of the machine is denoted by the letter eta. Eta is a Greek letter and how we have to write it? Write small n with the tail. That is called eta. Okay. And that is called efficiency of the machine. Now, efficiency of the machine is generally given by work output by work input. Work output by work input is called efficiency of the machine. And efficiency is generally expressed as percentage. Remember, efficiency usually we will express in terms of percentage only. Percentage means you know for 100 how much is the efficiency. So, in that case, what will be the formula for efficiency? You just see. Efficiency eta will be equal to output by input multiplied by 100. So, this is the definition for efficiency of a machine. So, in today's class, I have told you about some 8 terms related to simple machines. Which are those 8 terms, children? First one is load, right? Which is represented by the letter L. Second one is effort, which is represented by the letter E. Third one is mechanical advantage, it is the ratio of load to effort. Fourth one is what? Work input, means work done on the machine. Fifth one is work output. That is work done by the machine. Sixth one is what? Principle of a machine. What is principle of a machine? Work input must be equal to work output, because we know according to law of conservation of energy, energy is not at all wasted. You can neither create new energy nor destroy the existing energy, but you can convert energy from one form to the other only. So here also, whatever work is there, work is not at all wasted. Work done on the machine must be equal to work done by the machine, which is called the principle of the machine. Now what is the seventh one? Seventh one is velocity ratio. Velocity ratio is given as velocity of the effort by velocity of the load. This is called velocity ratio. And what is the eighth one? Eighth one is efficiency, which is given by output by input. Right? So efficiency is expressed as percentage. So I will write it as output by input multiplied by 100. So these are some of the 8 terms which are related to simple machines. So please go through your textbook and try to know all these definitions for various terms of the machines. In the next video, I will continue with the other topics. I will tell you what is the ideal machine, what is ideal mechanical advantage, what is actual mechanical advantage, then what is the relation between velocity ratio, mechanical advantage and efficiency. So these three are there, no, mechanical advantage, velocity ratio, and then what is that? Efficiency. These are the very important terms. There is a relation which relates mechanical advantage, velocity ratio and also efficiency. So what is that relation? That we shall learn in our next video. Till then, take care of yourself and keep studying. Thank you, children.